Okay, so today's topic, this is objective 7.3b, and today's topic is trig functions of any angle. So we've done a lot of trig functions with acute angles. Now we're going outside of that. Any angle, positive, negative, doesn't matter. Big, small, it doesn't matter. Okay, so how do I use the right triangle trig to find trig function values for angles of any size? So this goes like this. Many problems that you solve, real world problems, involve the use of angles that are not acute. They're not. And long ago it was discovered that you can extend the domains, all of the values of x, of the trig functions of acute angles to angles of any measure. Okay, so how do we do this? One way it was done was by plotting an angle on an XY coordinate plane, creating a circle to represent that circular motion and then measuring the angle using that circular motion, right? So if you draw a circle on a coordinate plane with the center at the origin, center of the circle at the origin, then you plot the angle that you're supposed to be looking at in standard position and label the angle theta. Then you create the acute. What you do is you create an acute angle. That's what you do. By connecting the point on the circle at the end of the terminal side of the x-axis with, you're going to connect it with a vertical line. So a point on the circle to the nearest x-axis with a vertical line, creating a reference right triangle and a reference angle theta. And you mark it with theta and then underscore or subscript capital R. That says theta reference. So that is the angle that we will be using and we will be referring to. Now you can use right triangle trig and Pythagorean theorem when you find angles, angle values, side measures, etc. Okay, so we're going to use these instructions here to find the 6 trig functions of these angles that you can see down in example A, B, and C. And you can see that angle A, or angle theta in number A, is a reflexive angle. It's a really big angle. The angle in B is even more reflexive and larger. And then angle C is just a obtuse angle, right? So we've never used right triangle trig on angles that aren't right triangles, but we can turn all of these into right triangles by doing this. So we're going to take this angle here, and we've got this nice circle, and I've given you a point on the circle that the terminal side of this angle passes through. So what we're going to do is you always connect that point on the circle that's on your terminal side to the nearest x-axis with a vertical line, and so that would go right there. And then you create a reference angle. Now your reference angles this is the thing that's hard for everybody. Your reference angles are created at the vertex, so at the origin. So your angle inside this little right triangle that we've just created, the reference angle has to be passing through the origin of that triangle. So we have some measures here. So we've created our right triangle, and this is negative 4. Let's try that again. That's negative 4. And then this measure here is negative 3. Okay, so we're going to use theta's reference angle here to find the 6 trig functions of this triangle. So I'm just going to extract it here. And while I know that triangles cannot have negative side measures, we need to keep track of those negative measures, because maybe we're just going to get a negative answer for our sine or a negative answer for our cosine, because we're not really inside this little right triangle. We're working on this whole angle, right? So those negatives are actually really important. So this is our theta reference. So this would be opposite, this would be adjacent. So we have opposite and adjacent, which means that we could identify what is the tangent of theta's reference. And what is the tangent of the whole angle theta? We could do that. So, but we need hypotenuse to find cosine and sine. So first, let's just find hypotenuse by using the modified Pythagorean theorem, right? Hypotenuse means a squared plus b squared equals c squared, then, right? Hypotenuse squared equals a squared plus b squared. And then you take square root of both of those, right? So that would be -3 squared. And guys, it's really critical when you plug it into your calculator that you tug parentheses around that -3 and -4 squared. Hypotenuse will always be positive on these things unless the hypotenuse actually lands on an axis. So that would be 5, right? So the hypotenuse is 5. So let's see. Let me just write this out. So our opposite is -3. Our adjacent is -4. And our hypotenuse is 5, right? I'm going to tell you all the time, when you find the hypotenuse, it's going to be positive. Now all I'm asking you to do is come down here and identify all 6 trig values for angle theta. So this is the opposite, adjacent, and hypotenuse for angle theta, okay? All right, but we use that little reference angle to help us figure that out. All right. So sine is opposite over hypotenuse. So that would be -3 over 5. I would like you to enter that as -3/5. Okay, cosine is adjacent over hypotenuse, or -4 over 5, which I would like you to enter as a -4/5. Tangent is opposite over adjacent, and that is -3 over -4, simplifies to +3/4. Cosecant, we'll zoom out a little bit. Cosecant is just the reciprocal of sine, so hypotenuse over or opposite. So that would be -5/3. Basically, you could just flip your sign over. Secant is hypotenuse over adjacent, and so we can just flip -4/5. So, oops, wrong one. Down here at secant, -5/4. And actually that negative sign should go out front. And then cotangent is just this reciprocal of tangent, right? So that would be 4/3. And so those would be all the trig function values of angle theta, which is this large angle up here in the picture. Again, we just created the little reference triangle so we could use the little reference angle to help us find our opposite, hypotenuse, and adjacent. And we were really careful to pay attention to those negative values. Let's try one more together and then you can do number C. Okay, so here we have angle theta. It's really big, right? And so we have this circle, and then we have this point on the circle that's on our terminal side. So again, what you're going to do is you're going to connect that point on the circle to the closest x-axis with a vertical line, like so, creating a reference right triangle. And so your reference angle, remember your reference angle has to be at the vertex of the, or has to be at the origin. So that's theta's reference. And we have these two values, right? This is your x, this is your y. So this is 1 and this is -1. Those are those values. You could put this down here at -1 if that helps you make sense. But I just like to put it on the vertical line of my reference triangle. So what I need again to find is the hypotenuse. And if you're okay, I'm not going to extract that triangle. I'm just going to find hypotenuse by taking the x squared plus the y squared, and that will give me my hypotenuse. So that's the square root of 2. All right, so there's our h. And then I'll go back with my colors here. So here's opposite of our theta reference, adjacent to our theta reference, and then the square root of 2 is our hypotenuse. So I'll organize that. Opposite is -1, adjacent is 1, and hypotenuse is the square root of 2. And this is for angle theta, the whole angle. All right, so now we can find our sine. I'm going to scoot this information down so we can keep it in the screen here. So for angle theta, we have sine, opposite over hypotenuse. So that's -1 over the square root of 2. I'd rather you not have that square root of 2 in the denominator, so we're going to rationalize. So that would be negative square root of 2 over 2. Cosine is adjacent over hypotenuse, so that would be 1 over the square root of 2. And I think you can probably get to the answer to that pretty quickly. Positive square root of 2 over 2. So it's interesting how the sine was a negative value and the cosine is a positive value. That happens in quadrant 4. All right, tangent is opposite over adjacent, and so that would be -1 over 1, simplified to -1. Cosecant is the reciprocal of sine, and I actually think I'd rather use this version, right? Hypotenuse over opposite, so that would be the square root of 2 over -1, or negative square root of 2. Secant would be adjacent, hypotenuse over adjacent, so that would be the square root of 2 over 1, or the square root of 2. And then cotangent would be adjacent over opposite, so that would be 1 over -1, or -1. And so there you have all of the trig value functions for angle theta in problem B. Okay, so let's think about C. So C, angle theta, you have this acute angle here, and what we want is to create a right triangle. So we're going to take the point that's on the terminal side at -1 square root of 3, drop a vertical line down to the x-axis, and then identify theta's reference angle, because remember again that it has to be an angle at the origin. So here's your opposite, your adjacent, and your hypotenuse. So your x is -1, your y is the square root of 3, right? You could put it up here at the square root of 3 if you want. And this would be -1 right here. Okay, but you have your picture of your triangle there. I'll extract it. So -1 square root of 3. There's your theta reference. Find the hypotenuse. Go ahead and press pause and then come back and see if you got the answer. Okay, so hopefully you gave that problem a go and you were able to identify that your hypotenuse was 2. So your opposite was the square root of 3, your adjacent was -1, and your hypotenuse was 2. I'd like you to notice that your hypotenuse in every situation was positive, okay? It's supposed to be that way. All right, so your sine was the square root of 3 over 2. Your cosine was -1/2. Your tangent was negative square root of 3. Cosecant was 2 square roots of 3 over 3. Secant was -2, and cotangent of theta was negative square root of 3 over 3. Okay, so let's just sum up a couple things. Notice that I gave you angles in quadrant 2, 3, and 4. Any of the angles in quadrant 1 would be your regular right triangles because they would be acute angles, or their reference angle would just be a regular little acute angles, and your x and your y would both be positive in that situation. So your sine, cosine, tangent, everything would be positive. In quadrant 2, you have a negative and a positive. Quadrant 3, negative and negative. Quadrant 4, positive and negative. And so when your angles, your terminal sides of your angles end in quadrant 2, quadrant 3, and quadrant 4, what happens is that will cause some of your trig functions values to be negative while others remain positive. So in quadrant 2, let's look at that first. Notice that your sine was positive and your cosine and your tangent were negative. Okay, so that's interesting. So of course, their reciprocals would be the same. So since sine is positive, cosine is positive, like that. Okay, in quadrant 3, what you'll notice is your sine and your cosine's values are negative and your tangent's positive, right? That's because your x and your y are negative. Negative divided by negative is positive, opposite over adjacent. And then in quadrant 4, your sine is negative and your tangent's negative, but your cosine's positive. So that's where things start to get a little bit difficult because you have to pay attention to the signs. So I'll give you a little reference for that later. Okay? All right. So here, let's move on to example 5. So this one ramps up the level of difficulty just a little bit. So if you feel like you need to spend a little more time digesting that first part, maybe open today's assignment and just do the problems that look like that for a bit. Make sure you've got it, and then come back and watch the next part of the video. Okay, so hopefully if you needed a break, you went and you did some practice problems and now you've come back, or maybe you were just ready to move on. So here's example, and is this example 5? Yeah, it is. So it says the terminal side of angle theta in standard position lies on the given line in the given quadrant. Find the sine, cosine, and tangent. So why is this a pain? Because I gave you a line, the equation of a line, and I'm telling you that I want the part of that line, because remember, lines will slash across the xy coordinate plane, but I only want the line in quadrant 3, and it says that the angle's in standard position. So basically, we want the terminal side to be over here in quadrant 3 somewhere. Okay, so let me erase that, and let's actually get a line. So here I've given you the equation of a line. So 3x minus 2y equals 0. Might be good to just put this in slope-intercept form so that you can graph it. So I'm just going to put it in y equals mx plus b. So negative 2y equals negative 3x. I'm going to go ahead and leave that plus 0 because that's your y-intercept. Divide by negative 2, and you get y equals the slope, rise 3, run 2x, plus 0. So that means that you know your y-intercept is 0, and it should be, because this is an angle that should pass through, have its vertex at the origin. Okay, and then rise 3 and run 2. But I can't really do that because that would put me in quadrant 1. I want to be in quadrant 3. So maybe instead of rising 3 and running 2 up and right, I'll go down 3 and left 2, down and left. That's also a positive slope. So I'm going to go down 1, 2, 3. Actually, I'm going to stretch it out a little bit more so I can have a good picture here. 1, 2, 3. 1, 2, 3. So from here, I'm just going to go down 3 and right 2. I could also go up 3, right? And then I could draw the line. But I only want the part of the line that's in quadrant 3. So the terminal side of angle theta in standard position lies on the given line in the given quadrant. Okay, so there's my terminal side. So now we're just going back to what we just did. So we're going to drop in our right angle so we can create, well, that vertical line that connects the point on this line. I don't have a circle here. You don't have to have one. Up to the y-axis. So this measures negative 2, this measures negative 3, and you are asked to find, well, what's the sine of theta? Well, here's theta's reference angle. Again, remember that the reference angles, I'm going to draw it in red so it's just standing out, have to be an acute angle that has its vertex on the origin. So there's your reference angle. Okay, so we're looking for the sine of theta, not the sine of theta's reference, just the sine of theta. Well, we'll use theta's reference to help us find it, the cosine of theta and the tangent of theta. Well, I already have the tangent of theta because I have opposite and I have, I'm going to go to red, opposite of theta's reference and adjacent. So I already know that it's negative 3 over negative 2, or 3/2. And I just need to remind you that tangent of theta is the slope of a line. All the time, tangent is slope. Pitch, slope. Tangent, slope. Okay, so once you found that information, you already knew the tangent. Okay, now we just need sine and cosine. So again, you find hypotenuse, right? So we're going to do the hypotenuse is equal to negative 2 squared plus negative 3 squared, plugging that into your calculator properly. What's that, 4 plus 9? So that's the square root of 13. So there's your square root of 13. And maybe you're organizing your information. So opposite is negative 3, adjacent is negative 2, hypotenuse is the square root of 13. So now you just have to find your sine and your cosine. So opposite over hypotenuse, rationalize your denominator. So that would be negative 3 square roots of 3 over 13. I'm going to scoop this over so it's not in the way of my other problem there. Zoom it in. All right, and then cosine is just adjacent over hypotenuse. So that would be negative 2 over the square root of 13 times the square root of 13. I'm going to just drag this stuff down here a bit. Okay, so we have more room. I apologize. Probably can't even see what's happening on the screen. There we go. All right, zooming in. So times the square root of 13 over the square root of 13. So that would be negative 2 square roots of 13 over 13. Okay, and so the level of difficulty is slightly more because you have to interpret what this means so that you can put it on a graph. So I'm going to have you try this next one. So press pause, give it a go, and then press play to see if you got it right. Okay. So hopefully you were able to graph a line with a slope of negative 3 in quadrant 4. So from 0, 0, you drop down 3 and right 1, and you put your point. And that point you connected to the x-axis to create that right angle and your reference angle, which again is at the origin. Okay, and then you're going to use theta's reference angle. That's going to be how you visualize or refer to this angle. So here's your opposite, adjacent, and your hypotenuse. So we found the hypotenuse again. In this case, it was square root of 10. So here's your sine, negative 3 square roots of 10 over 10, and actually I would prefer the negative to be at the bottom there. So let me clear that up. The cosine was the square root of 10 over 10. And the tangent of theta is the slope of the line. Slope is tangent, which is leading us to the last question. All right, so it says, given that the tangent of theta is the slope, rise negative 2, run 3, and theta, our angle theta, is in quadrant 2, find the other 5 function values for theta. So remember, tangent of theta equals rise over run, or opposite over adjacent. So negative 2/3. So if we're in quadrant 2, that means that our x is negative and our y is positive. And a tangent that's negative is going to run through either quadrant 2 or quadrant 4. So let's just visualize this. If our slope is negative 2/3 and we have to be in quadrant 2, then we're going to have to go up 2 and then left 3. And so that the terminal side is going to pass through that point right there. So here's theta. So we want to find all the trig function values for angle theta. Again, we're going to connect We're going to say that that's 3 because I didn't do it very good. Well, I'm going to just put it out there where it is. I'm going to just move that point where it should be. Okay. So again, we need this reference angle here. We need to connect this point on our terminal side to the x-axis and then look at our reference angle. So this is the angle that we're going to use to find our sine, cosine, tangent, blah, blah, blah. All right, so this is a rise of 2, right? And a run of -3, but I better put a -3 on that. So there's our picture. So we're looking for our hypotenuse again, okay? So we'll do hypotenuse is equal to the square root of 2 squared plus -3 squared. So I believe that would be 4 plus 9, square root of 13. So there's the square root of 13. So we have an opposite of angle theta, which is 2, and adjacent is -3, and a hypotenuse is the square root of 13. So the sine of theta, we're asked to find. So sine should be positive because I'm up, opposite over hypotenuse. They're both positive, so our answer should be positive. So that would be 2 over the square root of 13. Rationalize real quick. We get 2 square roots of 13 over 13. Your cosine of theta. This should be negative because your adjacent here is a negative. So -3 over the square root of 13 times the square root of 13 over the square root of 13 is -3 square roots of 13 over 13. We already have the tangent, which means, guys, we already have the cotangent. We'll just flip that baby over, -3/2. Cosecant, we'll flip over the sine. So the square root of 13, I apologize. So that's the square root of 13 over 2, and then the secant of theta would be negative square root of 13 over 3. Okay, so something that I'd like you to remember. This is just a little reference, just a little saying to help you remember what your trig values, functions, the function's values will be depending on what quadrant you're in. So I'd like you to remember this. A smart trig class. And how this reference works is like this. The first letter of each word, okay, is going to indicate the trig functions that would be positive in that quadrant. So in quadrant 1, all will be positive. Sine, cosine, tangent, all the values will be positive. In quadrant 2, sine is positive. Cosine, negative, tangent's value will be negative. In quadrant 3, tangent will be positive, and sine's value will be negative, cosine's value will be negative, and also the reciprocal values, okay? And then in quadrant 4, cosine. So cosine will be positive, and sine and tangent will both be negative. So that's just a little reference that you could have out by when you're doing your homework, just to make sure you're assigning the right sign. Is it a positive or a negative value for angles that are in each quadrant? And that is it. Hopefully you understood that lesson. Work on your homework and have a great